In the next few lessons, we'll look at tools needed to factor an expression, which is an important part of solving polynomial equations. To factor an expression, it means to rewrite the expression as an equivalent product. We're going to look at factoring the greatest common factor, or oftentimes referred to as GCF. That is their abbreviation for it. So when we say find the greatest common factor or find the GCF, what we're saying is to find the largest factor common to all terms in the polynomial. So let's start with what should be a review for you. We're going to find the GCF of 105, 40, and 60. And the way we're going to do it is to draw a prime factorization tree for each number. Starting with 105, we have to factor 105, we can factor it into 5 and 21. 5 times 21 is 105. Then 7 times 3 is 21. So our prime factorization of 105. We have 3 times 5 times 7. All right, let's do, I'm gonna do 40 off to the side. So we have 2 times 20 gives us 40. 2 times 10 gives us 20. And then 2 and 5 for 10. So our prime factorization for 40 is 2 times 2 times 2 times 5. And then if we do 60, we have 2 times 30. And then for 30, 2 times 15. And then for 15, 3 times 5. So the prime factorization for 60 is 2 times 2 times 3 times 5. Now let's look to see what is in common. 105 has a factor of 3. 40 does not, but 60 does. So that means 3 is not common. Next, 5 is a factor for 105. It's also a factor for 40, and it's a factor for 60. So 5 is common. 7 is a factor of 105, but not of 40 and not of 60. And 2 is a factor of 40 and 60, but not of 105. So our only common factor is 5, and therefore it is also our GCF. Okay, I'm going to use the same process, the same idea with 14x squared and 21x to the 4th. So we're going to find the GCF by first writing the prime factorization of 14x squared. So that will break down into 2 times 7 times x times x. Now for 21x to the 4th, that breaks down into 3 times 7 times x times x times x times x. So now what is in common? Well, there's a 2 for 14x squared, but not for 21x to the 4th. So that's not. But it has a 7 and 2 factors of x. Now what about 21x to the 4th? It has a 7 and 4 factors of x. So what is in common will be 1 factor of 7 and 2 factors of x. That is what they have in common. So our GCF is 7 times x, or in other words, we can just simplify it to 7x squared. That's our greatest common factor. All right, let's take a look at example C. We have 15a to the 4th, 27a cubed, and 6a to the 5th b. So let's find our greatest common factor. If I look at 15a to the 4th, I have 3 times 5 times a times a times a times a. 27a cubed. Okay, I have 3 times 3 times 3 times a times a times a. And then 6a to the 5th b. We have 2 times 3 times a times a times a times a times a times b. All right, so is 3 in common? Yes. 15a to the 4th has 1 3. 27a cubed has at least 1 3. And 6a to the 5th b has 1 3. So we can only take 1 because 15 only has 1. 27 has 3 factors, but it's not 3 for 15 and it's not 3 factors for 6. Okay, now what about 5? No, we don't have 5 represented in every prime factorization, but we do have at least 3 factors of a in each term. Now what about for b? Well, the last term, 6a to the 5th, has a factor of b, but the other terms do not, so it's not going to be common. So our GCF is 1 factor of 3 and 3 factors of a, or in other words, it's 3a cubed. Now, after a certain while, you can see it's not actually quite practical to continue writing out the prime factorization for every single term. So at some point, you're going to be able to do this mental math to be able to find the highest factor for your coefficients, then for your variables. So let's look at some examples where we can do it using mental math instead of writing out the prime factorization. All right, so we have the term here, 5v cubed w to the 8th and y 4th, okay? And then the second term is 30v cubed y to the 5th. So when you're using mental math to find the GCF, my recommendation is first to look at the coefficients between 5 and 30. What will be the greatest common factor, right? And looking between 5 and 30, 5. That is the greatest common factor for the coefficients. Now we'll go to the variables, v. The way to find the greatest common factor for a variable is essentially to take the lowest exponent. Here, they're both v to the 3rd power, so that is part of our GCF. Next, let's look at w. So the first term has w as a factor, but the second term does not, so that's not part of the GCF. And now we'll look at y to the 4th and y to the 5th. So again, take the lowest exponent. So we have y to the fourth in our GCF. All right, just to convince ourselves, why don't we do the prime factorization for this one, just to confirm. So starting with the 5 v cubed w to the 8th y to the 4th. All right, the prime factorization for that, you get 5 times v times v times v times w 8 times. All right, 1, 2, 3, 4, 5, 6, 7. Oh, I got them all. Awesome. And then 4 factors of y. So as you can see how impractical it is to always write out the prime factorization. And then for 30 v cubed y to the 5th, we have here 2 times 3 times 5, 3 factors of v, and then 5 factors of y. All right, so we have 5 and 3 factors of v, 4 factors of y in common. 5, 3 factors of v, and then 4 factors of y. So you see you have another y factor for this second term here, but you don't have another y to match up with it in the first term, so it's not in common, right? You have factor of 2 and 3, but you don't have the factor of 2 and 3 in the first term. You have all these factors of w in the first term, but you don't have factors of w in the second term to match up with it. All right, so it confirms that our GCF is 5 v cubed y to the 4th. Okay, let's take a look at E. We have here 20y to the 4th, v squared u to the 6th, and 25 v to the 5th, u to the 6th. All right, so again, try to find the GCF using mental math, starting with 20 and 25. Right, what would be the biggest common factor between those two? And I'm going to say 5. Okay. Next, how about y? Well, the second term doesn't have a y, so that's not going to be in our GCF. V squared and then v to the 5th power. Take your lowest exponent, that's what they have in common, so v squared. They'll both have at least 2 factors of v. And then u to the 6th and u to the 6th, that's the same, so u to the 6th. And there is our GCF. All right, so a little bit of review. Previously, we have here the expression multiply 7x squared, parentheses, 2 minus 3x squared, close parentheses. So we know that when we multiply this out, we're going to distribute the 7x squared to the 2 and to the 3x squared. And so 7 times 2 gives us 14. And then x squared minus 7 times the 3 gives us 21. And then the x squared times the x squared. Since you are multiplying, you add your exponents. And that gives us x to the 4th power. All right, so that's a review. what we're doing now is we're looking at the process of factoring, which in essence is to reverse the multiplication, to undo the multiplication, to write our expression as factors that are multiplied, right? A product of factors. So we have here 14x squared minus 21x to the fourth, and the direction says factor out the GCF. So essentially we're undoing the multiplication process, right? So when you're factoring out the GCF, the first thing you want to actually find the GCF the way we did in the previous examples. So we look at 14x squared and we look at 21x to the fourth. And we say, okay, what is the GCF? Between 14 and 21, we have the greatest factor would be 7. And then between x squared and x to the fourth, the greatest factor would be x squared. So 7x squared is our GCF. Then you're going to divide by the GCF to get the second factor. So I'm going to divide 14x squared by 7x squared. And I'm going to divide 21x to the fourth by 7x squared. All right, so I'm going to get 14 divided by 7 is 2. X squared divided by x squared is 1. So 2 times 1 is 2 minus 21 divided by 7 is 3. And x to the fourth divided by x squared. Remember, you subtract your exponent, so that's x squared. So we can see here, 7x squared was our GCF. And the 2 minus 3x squared, that was our second factor that we were able to get when we divided by the GCF. And that is how you can factor when you're factoring out the GCF. So let's take a look at some other examples. We have 18u to the fourth v squared y to the ninth minus 14u to the sixth v to the seventh. So first, we need to find the GCF. So I'm looking at 18 and 14. They have a factor of 2 that's in common. Anything else? No. Next, I'm going to look at u to the fourth and u to the sixth. Take the lowest exponent, so u to the fourth. V squared and v to the seventh, lowest exponent. So we have v squared. Now y to the ninth, but no y. So we don't include y because both terms do not have a y factor. All right, so we found our GCF. Second, we're going to divide to get the second factor. All right, so I know I'm going to multiply by something here once I get my second factor. So I'm dividing by 2u to the fourth v squared, dividing by 2u to the fourth v squared. Okay, 18 divided by 2 is 9. U to the fourth divided by u to the fourth is 1. V squared divided by v squared is 1. And then we have y to the ninth left. Minus. Let me make that look better. There we go. All right, 14 divided by 2, that is 7. U to the 6 divided by u to the 4. Remember, you're subtracting your exponents when you're dividing. So 6 minus 4 gives us u squared. And b to the 7 divided by b squared. Again, subtracting your exponents, so you have b to the 5th power. And we have successfully factored this expression by factoring out the GCF. Now you can check your work by multiplying. All right, so why don't I do that below? I wanted to check my work by multiplying. So I can see, do I have an equivalent expression? So we have 2u to the 4th, b squared, multiplied by 9y to the 9th minus 7, u squared b to the 5th, close parentheses. So distribute, and that's going to give us 2 times 9, 18. U to the 4th, b squared, y to the 9th, minus 2 times 7 is 14. U to the 4 times u squared, add your exponents, so that's u to the 6. B squared times v to the 5th, add your exponents, that's v to the 7th. And that matches our original expression, and so I'm feeling very confident about my answer that I wrote for factoring. All right, let's take a look at D. We have 21b to the 5th, w cubed minus 7b to the 9th, w squared x to the 7th. Go ahead and pause the video and try it, and then we'll do it together. All right, so first we're going to find the GCF. Between 21 and 7, 7 is looking real nice. All right, between b to the 5th and b to the 9th, the lowest exponent between those two is b to the 5th. W cubed and w squared, the lowest exponent, w squared. We don't include x in our GCF because both terms do not have the x. All right, so we have our GCF, and now we're going to multiply that to our second factor. And we have to divide by 7 b to the 5th w squared in order to get our second factor. So we get 21 divided by 7 is 3. B to the 5th divided by b to the 5th is 1. W cubed divided by w squared. Subtract your exponents, so you have w to the 1st power minus 7 divided by 7 is 1. B to the 9th divided by b to the 5th. Subtract your exponents, so we have b to the 4th power. And then w squared divided by w squared is 1. And then x to the 7th power. All right, so that is our expression factored, okay? And feel free to multiply that back out to check your work to see if you get the original expression. All right, sometimes when we are factoring, it just makes sense to factor out a GCF that's negative. It's going to be very helpful to us as we're factoring. And oftentimes I make that determination by looking at the leading coefficient. So you see here, we're asked to factor out -3 from the polynomial -3x squared plus 6x minus 33. Notice how the leading term has a negative coefficient. That's oftentimes a big indication as to whether you should consider factoring out a GCF that has a negative coefficient. So here we're told to factor out a -3. So we don't need to make that determination ourselves. But when you do, keep that in mind. So we're factoring out a -3. So I'm going to write -3 parentheses. And now to get the second factor, you have to divide each of these terms by -3. Be careful of your signs. Negative divided by negative is a positive. 3 divided by 3 is 1. And we're left with the x squared, 1x squared. Next, positive divided by a negative is a negative, so I'm putting minus. 6 divided by 3 is 2. And then we have an x. Negative divided by a negative is a positive, so I'm going to put plus. And then 33 divided by 3 is 11. Done. Again, multiply this back out to check your work to see if you get the original expression. All right, we have here, factor out the quantity, -4p³ from the polynomial -12p³ q minus 8p² q² plus 4p³ to the third power. Go ahead, pause this video, try this on your own, then we'll do it together. All right, so I'm going to start with writing the -4p³ as our first factor. And then I'm going to divide each of these terms by the -4p³ to get the second factor. So starting with the first term, a negative divided by a negative is a positive. 12 divided by 4 is 3. p³ divided by p to the first power, subtract your exponents. 3 minus 1, p to the second power. q divided by q is 1. All right, next we have -8 divided by -4, that's +2, so we have +2. p² divided by p to the first power, so we have p to the first power. q² divided by q to the first power, so we have q to the first power. Next, +4 divided by -4, that's a -1. I'm going to just put minus for now. All right, p divided by p is 1. q to the third power divided by q to the first power, subtract your exponent, so that is q². Voila. Okay. Okay, up until this point, all of our GCFs have been monomials, but that is not always the case. A GCF can really be any factor. So if we look at the expressions that are given for part A, it says, what is the GCF? 3x parentheses a plus b close parentheses and 2y parentheses a plus b close parentheses. Now let's break this down. 3 is a factor. X is a factor. And a plus b is a factor. It's not, the factor is not a, the factor is not b. The factor is a plus b. Now, if we look at the second expression, we have 2 is a factor, y is a factor, and again, a plus b is a factor. So when we think about, okay, what is our GCF? We only have one factor that is in common, and that is the a plus b. All right, so now look at the second part here. It says factor completely. Now we have it written as an expression 3x parentheses a plus b, close parentheses, plus 2y, parentheses a plus b, close parentheses. So we have a product plus a product, and we're asked to factor this. So as before, remember you had to first find the GCF. So I'm going to write that down. And then you divide by the GCF to get your second factor. So if we look here, the 3x is left for the first product, plus the second product we have left 2y. And that is factored. All right, let's take a look at C. We're going to factor completely 2w parentheses x plus 3 close parentheses plus 5 parentheses x plus 3 close parentheses. So again, first, find your GCF between the two products. So I can see that we having x plus 3 in common. So I'm going to divide each product by x plus 3. So what is remaining is 2w plus 5 as our second factor. All right, so there we go. We have completely factored that expression. Okay, example D, we have 4ab parentheses a plus 2 close parentheses plus 5a parentheses a plus 2 close parentheses. All right, pause the video and go ahead and factor that. All right, this one was a little bit different. You do have a plus 2 in your GCF, but you also have an a as a common factor. So we can see here, there is a single a that's a common factor and the a plus 2, right? So a times a plus 2 is our GCF. All right, so now that we have our GCF, now we're going to divide by the GCF. And now that's going to give us our second factor. So the a's reduce to 1 and the a plus 2 reduces to 1. So what we have left in the first product is a 4b plus, and then in the second product we have a 5. All righty.